Hello and welcome to this class on web scraping essentials with Python, requests and BeautifulSoup. My name is Andrei Dumitrescu and I'll be your instructor for this class as well as lots of other classes here on Skillshare. Since this is intermediate Python, you are required to already master the basics of Python before enrolling into this class. My advice is to first check my other classes on Python published here on Skillshare. They will help you build a strong foundation of Python programming language. Web Scraping Essentials with Python, Requests and BeautifulSoup will teach you one of the most hottest topics of the data science industry. Web scraping is a technique used to extract large amounts of data from websites and save the extracted data into a local file or to a database. In this course, you will learn how to perform web scraping using Python, Requests and BeautifulSoup, probably the most used open source library written in Python for parsing HTML documents. In this course, you'll get the web scraping skills in Python to move ahead. This hands-on course goes straight to the point without any distraction and focuses solely on how to scrape web pages using Python, Requests and BeautifulSoup. If you want to waste no more time with incomplete scripts or tutorials, copy-paste solutions or confusing source code, then this class is for you. See you in the class. In this section, we'll start talking about web scraping using Requests and BeautifulSoup. First, let's see what does web scraping mean. Web scraping is the process of automatically mining, collecting or extracting data from websites using the HTTP protocol. Web scraping is a two-step process. The first process involves fetching or downloading the web page from the server using the HTTP protocol. Once fetched, the second process, which is extraction, can take place. The content of the page may be parsed, searched, or copied into a spreadsheet or a database. Web scraping is getting more and more popular every day. It is used for brand or price monitoring, stock market tracking, tracking latest trends, or for building machine learning models. Let me show you some examples of how useful web scraping can be for you. Let's assume you are interested in buying or renting a property. Gathering information about every single property listed in your city is not a small task. And for this reason, many companies are actually taking the help of web scraping services to help get more listings on their websites, as well as help more people get their perfect property. You could develop your own Python web scraping script that crawls and extracts data about each property listed on major real estate websites. Your script could save the extracted data in a spreadsheet or in a database for you to see it. Or, if you are an investor, getting stock exchange closing prices every day can be a pain, especially when the information you need is found across several websites. You could make data extraction easier by building a web scraper to retrieve stock indexes automatically from the internet. At the beginning of this lecture, I said that the first process of web scraping is fetching or web page downloading. For this purpose, we use a very popular library called Requests. Requests is a Python HTTP library, and its goal is to make HTTP requests simpler and more human-friendly. It allows you to send HTTP requests and add content like headers, form data, multi-part files, and parameters like authentication data from Python scripts. It also allows you to access the response data in the same way. After fetching the web page using requests, we need to pull data out of HTML files. Here, BeautifulSoup module comes into play. It helps us to parse the web page, extract the desired information, and present it in a format we can easily make sense of. This was just an introduction about web scraping and how useful it can be, and in the next lecture, we'll set up the environment needed for web scraping, install and see how to use the requests and BeautifulSoup modules. See you in a few seconds in the next lecture. The requests and BeautifulSoup modules required for web scraping don't belong to Python standard library and we have to install them. For that, we'll use pip, the Python package manager. So, in a terminal, I write pip install requests, a white space, and bs4. bs4 is in fact the module that contains the BeautifulSoup class used for web scraping. To test whether it is installed correctly, try to import the modules in a Python shell. So import requests, bs4. If there is no error, we assume it has been installed correctly. If you get a name error, such as name requests or bs4 is not defined, there was a problem with the installation of the modules and further troubleshooting is required. Now, if you are using a virtual environment, which is an isolated environment for your application, you need to install the modules also in that virtual environment, not only global, like we did before. For example, the latest version of PyCharm creates a virtual environment for each new project. In this case, we must install the modules also in the virtual environment. Go to File, Settings, Project Interpreter, click on the plus sign, and write Requests. Click on Requests, install package. And package requests installed successfully. Now we do the same for bs4. bs4 installed successfully. Let's test it whether they have been installed correctly. So import requests, bs4. And there is no error when running the script. Now that we have everything set up, we'll start working with these modules and see how web scraping is done. In this lecture, we'll take a closer look at Requests Library. The first thing we'll need to do to scrape a web page is to download the page. We can download pages using requests. The Requests Library will make a GET request to a web server which will download the HTML contents of a given web page for us. There are several types of requests we can make, and GET is one of them. By the way, another possibility to retrieve data from a web server is to use an API or application programming interface. Sites like Reddit, Twitter, and Facebook all offer certain data through their APIs. APIs are a way to serve customers. Companies are packaging APIs as products. For example, weather websites sell access to their weather data API. APIs are applications hosted on web servers. Instead of using a web browser to ask for a web page, your program asks for data, and the data is usually returned in JSON format. The same requests library is used to communicate with APIs. Anyway, the majority of websites don't offer an API, and in that case, a manual web scraping is required. However, APIs are not a topic of this section. Now, let's go to coding and see some examples of using the requests library. First, we import the module. After that, we create a variable called URL that holds the address of the website. Let's say http://www.python.org. Take care, HTTP is mandatory. If you don't use HTTP or HTTPS, you'll get an error. Now, I'll create a variable called response equals requests.get of URL. Let's see what is the type of the response object. Print type of response. And we see it's a requests response object. Now, let's talk about HTTP status codes. Status codes are issued by a server in response to a client's request made to the server. All HTTP response status codes are separated into 5 classes or categories. The first digit of a status code specifies one of 5 standard classes of responses. There are 5 values for the first digit. If the first digit is 1, it means that the request was received and the process continues. 2 means successful, so the request was successfully received, understood, and accepted. 3 means redirection, and 4 and 5 mean errors. Let's see what is the HTTP response status code of our response object. Print response.statuscode. And we see it's 200, which means the request was successfully received, understood, and accepted. What if we modify the address of the website this way? /a.html. Let's try to access this page in the browser. And the browser displayed error 404, file not found. Now let's try it from Python. And we see the same error code. Now the status code is 404, which means that I've requested a resource that doesn't exist, or page not found. I'll make the URL correct again. Another useful attribute is OK. It returns true if the request was successful and false if not. So print response.ok. And it returned true. But what happens now? Here I add a.txt and I'll execute the script again. And the OK attribute returned false. Okay, the next step is to see the contents of the page. For this purpose, there are 2 attributes, content and text. Response.content is the content of the response in bytes. It will return an object of type bytes. I'll execute the script. We see the letter B, it comes from bytes, and this is the content of the page as bytes. Being a bytes object, I can decode it to a string. For that, I'll use the decode method. And I'll execute the script again. And it returned a string. In fact, this is the HTML source of the page. it's the same content I see here. There is also the response.text attribute that returns the response in Unicode. I'll comment out these lines and I write print response.text. And this is the content of the page in Unicode. In fact, it's the same content we've seen before when we've used the decode method. We can see the encoding scheme used to decode when accessing response.text object using the encoding attribute response.encoding. And the encoding scheme is UTF-8. If we are not happy with the proposed encoding scheme, we can change it by modifying the encoding attribute. Now, let's take a look at headers. HTTP headers allow the client and the server to pass additional information with the request or the response. An HTTP header consists of its case-insensitive name followed by a colon, then by its value. Using the headers attribute, we can see a case-insensitive dictionary of headers of this response. Response.headers. And these are the headers. The header name is server and its value is nginx. This is the web server. Content type text/HTML and so on. These are the basics of requests library, and in the next lecture we'll see how to use the BeautifulSoup library and how to combine requests and BeautifulSoup to scrape the content of web pages. See you in the next lecture. Hi and welcome back. In this lecture, we'll learn how to scrape using the Python well-known library called BeautifulSoup. This library navigates through the HTML code of the web page and extracts the data. It doesn't actually download the page. For this, we use the requests library. Let's go coding and see exactly how it's done. For this example, I've created a very simple HTML file and put all its content into a variable. This way, it will be easier for you to understand in detail what happens. Of course, there is no problem if you want to download the page from the internet. You just have to import the requests module, get the page, create a response object and pass the response.text object, which is a giant string, to BeautifulSoup. This is what we've done in a previous lecture, and we'll also see some examples in the next lecture. Our HTML variable contains some basic HTML tags, some paragraphs, a div tag, some links, and other HTML stuff. You need some very basic HTML knowledge to understand that. And we begin the scraping by creating a BeautifulSoup object like this. Soup equals BeautifulSoup of HTML, my variable, and the second argument is HTML.parser. This is a string. BeautifulSoup can also parse XML content, but in this case we want HTML, so we use HTML.parser. It's very important not to forget to import the BeautifulSoup class from BS4 module. So from BS4, import BeautifulSoup. BS4 is the module and BeautifulSoup is the class we'll use. After creating the BeautifulSoup object and parsing it, we can navigate through the HTML code. There are several ways to navigate. By tag name, using find method, which finds one matching tag, using findAll method, which returns all matching tags as a list, and using CSS selectors. Let's start using the tag name. And I can do print soup.title, and it will return the title tag. Or I can do print soup.body. Of course, it will return the body of the page. I can go deeper into the body tag and write soup.body.div. And it returned the div tag inside the body. If there are more divs, it returns only the first one. If you need all the divs, you use another method called findAll. We'll see in a minute what it's all about. Even if the output looks like a string, it's not a string. It's in fact an object of type tag. I'll take it into a variable, let's say d equals soup.body.div, and now print type of d. And we see that d is of type tag. Let's move further and see the find and findAll methods. If I write print soup.find of div, it will find and print out the first div tag. This is the div tag. Let's try again using the p tag instead of div, so p. And it returned only the first paragraph. If you want all tags, like say all p tags, you should use the findAll method. And instead of find, I use find_all. And it returned a list that contains all p tags in the HTML code. We see here the first paragraph, the second paragraph, the third paragraph, and so on. We see also the paragraph inside the div tag. Now, if we want the text inside the tag, we use the text attribute of any tag object. soup.find of div.text. And it returned the text inside my div tag. findAll returns a list, so I can also iterate over that list. Let's say for x in soup.findAll of p, it will return all p tags as a list, print x.text. And it printed out the text of any paragraph tags in our HTML code. The findAll method also takes in a list as argument. For example, print soup.findAll and the list as argument. This is a list. The first element is div and the second element is p. It will find and return all div and p tags as a list. This is the list. It contains all p and div tags. The next thing I'll talk about is selecting using tags attributes such as ID or class. In our HTML code, there is a p tag that has an ID called myID. If I want to select all p tags that have that ID, I write soup.findAll, the name of the tag, p, and the second argument is id equals and the name of that id, in this case my id. And it selected only the p tag that has that id. Now if I want to select by class, for example, I want to find and retrieve whatever div tag that has a class called some class, I write soup.findAll. The first argument is the tag name div, and the second argument class underscore equals and the name of the class, some class. And it selected and returned only the div that has that class. Take care, the name of the function's argument is class underline and not class. Class is a reserved keyword in Python and it's not recommended to be used as a name for a variable or an argument. In the last example of this lecture, I'll show you how to find and retrieve all anchors or hyperlinks in a page. In our example, there are two links. I create a variable called links equals soup.findAll. The first argument is the name of the tag, in this case A, and the second argument, href equals true. And print links. And it returned a list that contains the links of my page. It's better to use the href equals true argument because there can be A tags without an href attribute. If I just want to retrieve the href value or the URL, the address of the hyperlink, I do. For link in links, print link.get and the name of the attribute, in this case href. It will return the value of an attribute of a tag. And these are the addresses or the href values. In the next lecture, we'll start a real web scraping project using requests and BeautifulSoup. In this lecture, we'll start a real-world web scraping project using requests and BeautifulSoup. We start with a disclaimer. While scraping can sometimes be used as a legitimate way to access all kinds of data on the internet, it's also important to consider the legal implications. There are many cases where scraping data may be considered illegal. This lecture is purely intended to be educational and nothing else. Before starting scraping, check the policies of individual websites and scrape at your own risk. Now, let's take a look at IMDb, the Internet Movie Database, which is the world's most popular and authoritative source for movies, TV, and celebrity content. I've sorted by number of votes in descending order all movies released in 2019. On each page, you see the first 50 movies. I want to fetch the page using requests and then parse and retrieve some data using BeautifulSoup. I am interested in the movie name and its rating. After retrieving the name and the rating, I want to save them in an Excel file for future use. Before starting the project, let's discuss about some aspects. All the pages we want to scrape must have the same overall structure. This implies that they also have the same overall HTML structure. So, to write our script, it will be enough to understand the HTML structure of only one page. To do that, we'll use the browser's developer tools. If you are using Mozilla Firefox or Google Chrome, right-click on a page element that interests you and then click Inspect. This will take you right to the HTML line that corresponds to that element. You can also do this using both Microsoft Edge and Safari. Notice that all the information for each movie is contained in a div tag, and that div tag has an attribute class named lister item content. There are a lot of HTML lines nested within each div, and you can explore them by clicking those little gray arrows on the left of the HTML lines corresponding to each div. Within these nested tags, we'll find the information we need, like a movie's name or a rating. Now, let's start coding. First, we import the requests library. Then, we import the BeautifulSoup class from BS4 module. Then, I'll create a URL variable that stores the address of the website. Like before, we create a page object equals requests.get of URL. If I want to test the script till this point, I write print page.ok. If it returned a successful status code, the OK attribute will be true. And it's true. Then I'll create a soup object equals BeautifulSoup of page.content, comma, the second argument is html.parser. Now we start the selecting and data retrieving process. We saw earlier that the information for each movie is inside a div, and that div has a class attribute with the value of lister item content. So I write content equals soup.findAll. There are many movies, so many divs tags. The name of the tag is div, and the second argument, class, with a trailing underline, equals, and the name of the class. So lister minus item minus content. Then I create a variable of type list called movies, where I'll save the name and the rating of each movie. So movies equals list, an empty list. Now I'll iterate over the content. So for item in content, colon, and the for block of code. Let's check the content of the page one more time using inspect element. We begin with the movie's name and locate its corresponding HTML line by using inspect element. You can see that the name is contained within an anchor tag, and this tag is nested within a header tag, a h3 tag. And this tag is nested within our div tag, the tag we've selected. So in order to retrieve the name of the movie, I write name equals item.h3.a.text. I only want the text of the anchor. Now that we've got the name of the movie, we'll focus on extracting the IMDb rating of the movie. Using the inspect element again, we notice that the rating is contained within a strong tag. And rating equals item.strong.text. Now that I have also the rating, I'll append both the name and the rating to the movies list. So movies.append, and I'll append them as a tuple, name, rating. I'll have a list of tuples. And I can check the content of movies list to see whether I've fetched the information correctly. So print movies. Let's execute the script. And it seems okay. Keep in mind that this is a trial and error process. Maybe you don't retrieve the information in the first place, but you have to continue trying. In this case, we were lucky. Now that we have the information, it's time to save it to an Excel file. I am importing the OpenPyXL module, and I write wb equals openpyxl.workbook. I am creating an in-memory workbook, so a new Excel file. Then I get a reference to the active sheet. Sheet equals wb.active. I am setting the title, sheet.title equals IMDb movies. And I'll write some cells. These are the headers. So sheet of A1 equals year, and sheet of B1 equals movie. This will be the header line of the spreadsheet. Having the movies and the rating in a list, I'll iterate over the list and append each movie and each rating to the file. So for movie in movies, sheet.append of movie. After appending the information, I must save the file. In fact, this will create a new file, a new workbook. wb.save of and the name of the file. Let's say movies 2019.xlsx. And I'll run the script. Okay, there is no error. And let's see if a new file called movies 2019.xlsx appeared in the current working directory. And this is the file. Let's open it. And inside the spreadsheet, we see the content we've retrieved from the website.